Motor oil is the #1 consumable product in the United States. According to the American Petroleum Institute, 56% of all lubricants produced in North America are comprised of motor oils. We've used time-tested and proven chemistry that has developed the highest TBN that's available in North America today, and it goes without saying that we meet and exceed the SAE requirements. Simply stated, when we safely carry you more than twice your normal change intervals, what we have accomplished is we've cut your oil consumption in half, we've reduced your filters and inventory by 50%, and we reduced the labor costs that are involved in that process. And let's not forget equipment availability. The process utilized to develop a modern 15W40 engine oil involves a myriad of tests that are designed by the American Society of Testing and Materials, ASTM, one of which, for an example, would be this oil must qualify and perform as a 15-weight engine oil at exactly 0 degrees Fahrenheit. This is pure sulfuric acid. It's about 10 times the strength of normal battery acid. And you want to know where this comes from. Your engine creates it, your own chemistry lab. It takes between 7,000 and 9,000 cubic feet of air to burn a gallon of diesel fuel. And in that 9,000 cubic feet of air, and depending on atmospheric conditions, you could have over a gallon of water. And the water combines with the sulfur in the fuel, forms trioxides. The trioxides generate a lot of heat, and when this happens, it converts to H2SO4, or sulfuric acid. The sulfuric acid is what carburizes and hardens, and this becomes soot. Soot is what gets around the valve seats so they can't properly seat over a period of time, and it does take a period of time, but when that happens, you start to lose power and performance and fuel economy. And it also gets around in and around your rings so they can't expand and contract like they're supposed to and wipe the cylinder liners. And what happens is you get downward blow-by into the oil, and that depletes your total base number alkalinity. And to give you a little idea of what this will do, I'll put a little bit on this paper towel. This is 10 times the strength of battery acid. I'm going to heat this oil. And the first thing we're going to see are some bubbles. The oil is doing its job. It's trying to carry the heat away from the source. The second thing we're going to see are light wisps of smoke. This is the lighter fraction of the oil cooking off, going off through the catalytic converter and into the atmosphere. The tree huggers call this NOx and SOx. You and I might call this add oil. As these lighter fractions roll off, it leaves the medium and heavy fractions of the base stock, and then the oil starts to oxidize or thicken. But really, not a whole lot is happening to this oil outside of a little bit of smoke and color. But watch what happens when I add the contamination. Once that oil has expanded and contracted, it's lost all of its alkalinity. It has no more service value to an engine oil. It looks and smells like your engine oil when you're changing it, doesn't it? That's the chemistry that takes place. With the second vial of oil, what I'd like to do is consider that you change your oil at 250 hours or 10,000 miles, which is what Caterpillar says is the equivalent. In order for me to recreate in a minute or so what you do in 250 hours, it's going to take a couple of inches of oil and 5 drops of acid in a couple of inches of oil. Now I'm going to mix this up. Okay. For our metals, if you would, bear with me. I don't have any bearings and liners with me today, so if you would, we'll consider these paper clips and this copper as our bearings and liners in a combustion engine. Basically what we're waiting for is for the oil to expand as it did just a few minutes ago. And on the modern oils, it generally takes anywhere from 30 to 45 seconds. And again, when it expands and contracts, we're through with the engine oil. It's done its job. Okay, we're at 25 seconds and the oil it's basically done. I've got to go to 30 seconds because I want you to see what happens with the heat. Now we'll insert the thermometer, and it won't take long for it to peg out. We're beyond 500 degrees. Now keep in mind, I am stressing the oil. As you can see, we've gone beyond the threshold of 500 degrees plus. Over the years, I've experienced shooting temperatures at the cylinder head better than 1,000 degrees on heavy CAD equipment offshore. So we're not getting outside of the bounds here. This is our 15W40 parasynthetic engine oil. And the first thing you'll notice is that it's green. The reason it's green is we've incorporated over 250 parts per million of a soluble moly. Many of you have experienced the usage of a disulfide grease. That is a ground up mineral in a 3 to 7 micron particulate size. This is the next generation. It's a trioxide. It's solubilized and will not settle out. The moly has a natural affinity to metal. And what I mean by that is it plates. It doesn't become a part of the surface, but it actually plates on the surface, much like a snakeskin. And if you consider a rotating assembly under heavy load on a hot day, you're going to break film strength. And when that happens, two pieces of metal come together, they cold weld and tear, and an invisible piece of debris flies off, and that shows up in an oil analysis as a wear metal. And with the moly coating and plating, and it's sacrificial, it must give itself up and be replenished, but those two pieces of metal cannot come together. They slide over one another. And when that happens, it reduces friction, and it ultimately reduces heat. Okay, now I'm going to add the sulfuric acid. Five drops. And what we'll initially see is the oil will actually turn brown as opposed to the emerald green. What we'll now see is the engine oil has actually changed color. There's a considerable acidic value in this oil right now, and the oil additives haven't been activated. They're heat activated, in fact. So what we're going to do is start our torch, add our penny and our paper clip, and we're going to hold the temperatures for the same 30 seconds as we did with a conventional oil. And what you'll be able to see is this oil will actually return to its original color as the additives are activated. It goes back to green. Now watch what happens with the thermometer. 30 seconds. In our conventional oil, we went beyond 500 degree threshold. And this oil is being reduced to approximately 250 degrees. What a lot of people don't realize is that dirty oil actually retains heat. I can go back to the oil that has had a few minutes to cool off, and what has happened is the thermometer again climbs. That's wasted energy. The heat is actually utilizing base number, and you're not moving the equipment. That's wasted energy. I think you can see between the two, conventional oil versus our 15W40 parasynthetic, that we have a good grip on being able to control heat. But what I think will impress you the most, because of how you work your equipment and what kind of arenas that you work in, I think what you'll appreciate is what the contamination side of this looks like. let me explain what happened here. What we've learned over the course of this program is that soot actually has two life cycles. When it's first created, it's a submicron particulate that is racing through a motor at approximately 26 gallons a minute. It's carbon, it's hard, it has to grab metal, and that's exactly what it does. But eventually it rounds itself out and becomes a non-abrasive and a non-issue. But when the base number fails, what happens is these small submicron particulates that the human eye can't see come together and they form larger asteroids. And this is where damage occurs. You've had the same amount of contamination, same amount of heat, same amount of oil. And the bottom line is we can keep those small, infinite non-abrasives in that state for a much longer period of time. That way, the oil is going to run cleaner. And if you'll notice on the back of this penny, the surface is almost dry. There is no more lubricity left in this penny. And when we look at our engine oil and the result of the bearings and liners, what we have is an oil that still retains its lubricity. The oil still has tenacity. And if you could feel this, it would be a very slick feeling because of the parasynthetics involved. On Tier 3 and Tier 4 engines, we've consistently seen 750 and 1,000 hours, again, done safely through an independent third party, a world-renowned oil analysis laboratory.